So a lot of times when I'll be printing, say for instance, this Metamason part, not only was this eggshell sort of like the eggshell technique really useful to it, but one of the things that was really important is the orientation of this part during printing. For instance, it only works when printed in one orientation, or it only works efficiently enough for you to use with one orientation during printing. And so I have the part with me here that I'm just going to hold because it's easier than describing and trying to pull it up on the internet. So we've got their original part here, which was printed in this case I printed it again in SLA, but they would print this in wax. And so this would be melted out, and when it's printed in a wax material and you're melting out the support material, orientation doesn't matter as much. So unlike an MJP, an SLS, a CJP machine, anything with basically a powder bed or a sort of melt away or wash away support system, the orientation isn't as important to the printability of the part. Where in SLA, because it's got support structures that I have to remove later, it is very important. And so if I can put it in such an orientation where I can minimize the amount of support structures on the object, the better the overall part comes. And so in this case, this part only prints at that orientation. Like you can print it at other ones, but at any other orientation, the support structures on the inside become so time-consuming to pull out, it's no longer a cost-effective way of making this part. And so a lot of times when I'll send parts to Quick Parts, or other random like service bureaus like Shapeways or whomever you're sending them to, I'll pre-orient them. And so a lot of softwares like Magix and our 3ds Sprint is another one, and Mesh Mixer, you can orient parts based on predetermined parameters like support area or print time, or there's, depending on what you want, there's a couple of different parameters. And so I'll orient it before I send it to them, because a lot of service bureaus just accept parts and print them out. And they'll just send you whatever crap you gave them. And so, like, that's the term is like crap in, crap out, or whatever that term is. And so, shit in, shit out, that's the term. But like, it's really important to sort of send them as much information up front if you care. So that's the, like, for instance, if a particular part, if you're having issues with orientation or something, you should orient it yourself and then send it to them. And then normally, because they'll just cycle through it and print it out, but literally printing this like this is, say, as an example, $5 to make this part. If I print it like this, if I print it upside down, it's now $20. The material is the same, everything is the same, but the amount of time it takes to pull the supports off is now 5 times more difficult, or maybe I can't even pull the supports out of the inside of this. Like on this structure, there's no supports on the inside. That was one of the tricks with eggshell, is orienting your parts in such a way that you don't have any supports on the internal structure that you're trying to fill with silicone, or if you do someplace that you can pull those supports out so you don't have your silicone full of SLA parts, which is probably not optimal. And then this also applies to like DMP as well. So for metal printing, if you can design your part to be basically self-supporting, and so basically having nothing exceeding a 45-degree angle, that could either be through orientation of your part. Say if you have a part that you can't redesign, you can spend some time to orient the part, and there's normally, I've yet to find a part that I couldn't orient to basically have like a perfect orientation where I only had a very minimal amount of support structures on it. It may take 15 or 30 tries just on the software, literally just like clicking support and being like, I don't like that. It's got supports all over this like surface I would like perfectly smoothed or anything like that. And so maybe I reorient it again, and maybe now the perfect orientation for this part is at some crazy angle. Like it's rarely flat. It's at some crazy angle, and maybe it makes my print twice as long, but maybe that's totally worth it for me if I cannot machine it later because I don't have supports on half of the part, or that maybe it saves all of the internal structures on these parts. And so orientation is very important, even in the design process. Like if you're trying to go really thin, a lot of times you have to figure out the minimum resolution of your machine. And so I'll do some experiments where I'll basically print a bunch of sheets that vary in thicknesses from 0.5 down to, or from 1 millimeter down to whatever I think will disappear. And so, and then the slicing software, I don't even have to print these a lot of times. A lot of times I can just open the slice file and scroll through it and see at like, oh, everything under 0.3 millimeters disappears. Nothing I should design should be under 0.3 millimeters. And so that'll be my like basically constraint at the small end is 0.3 millimeters, or on the big in the other direction, maybe when I'm printing a big solid block of something, and I realize like every time I do it, I get this weird warping along the top of this part. Maybe that's the moment to either, do I need the part to be solid? Maybe I go to the geometry and I hollow that part out, and so it's not a solid part anymore, then maybe that gets rid of the warping. Or maybe I've pulled a lattice structure on the inside, and that gets rid of the warping, which is a possible way of doing it. Or maybe I like tweak the machine and tweak the build parameters inside of the machine. And so depending on if you own a machine versus if you're sending it to a service bureau, I don't know, or I don't have as much experience with giving service bureaus specific parameters to build in, mainly because I'm an internal to 3D system, so I have slightly different directions I give them than someone external to a normal service bureau. Like I don't know if I could just ask Shapeways to, can you please turn your border overcures down to this tiny number? They might do it. If you're like a regular customer of them, totally. They will totally help you print parts and work with you to get the orientations down and all of the possible settings. We have some customers that have are like, we call them super users, but they're the people who we've worked with for like a good chunk of time to basically refine their one printing process. Like Meta Masons is an example. We sat and worked with their design team, and they would come over to our office and we'd sit down and work together to try and figure out what's the best way to print this part. Yes, a 3D printer can print it most of the time, like 99% of the time. If I stick something in the printer, it'll print it, but it might be so covered in supports that I can't get it off, there's no point. And so there's that. A lot of times, like for instance, this is an example of like, because the first people they had contacted, like a Meta Mason had come in contact with, was people who sold wax printers. And so they were, of course, trying to give them a wax printer. But over some time, like you have to kind of sort of look at all the possible materials and all the possible like printing types that are available to you. And hopefully there are experts, and there are at most companies, that will direct you to the correct type of thing. Like if you're like, I have this part that I think should be printed in like titanium, and they're like, no, really, you could get away with like a plastic part and it would be 1,000,000 times cheaper or something like that. And maybe you never realized that you could even print in plastic, or vice versa. Maybe you've been trying to print something in plastic and get it really strong, and you've spent thousands of dollars working with a service bureau to like refine the settings on the machine. Like we've changed the hatch spacing and we've changed all of those little parameters to get you just the optimal part. And then maybe printing it in titanium or Inconel is the actual answer, and you can first try, it already exceeds your expectations. And so knowing when and where to use the printers and the materials is very important. And so that's sadly like an experience type of thing. There is information online, but to my knowledge, a lot of times I'll send it off and have it printed in like 3 different materials, and then have them come back and then test all the materials and be like, actually, I really like Jewel way more than I like clear, or for this particular application, this wax works way better than this wax, because it like some waxes are dyed blue for whatever reason, some waxes are dyed green, some waxes just come as white. Maybe if you're like filling you're like casting something in silicone and you need it to be a really nice clean white silicone, putting it in a blue wax mold might change your silicone blue, or just a tint of blue or something like that. So you should know, and you might not know that until you do it though. And so that's a lot of times, like maybe you have the part printed and then you fill it full of silicone and you're like, oh no, it's blue. That doesn't mean printing it in wax is the end. That just means that specific wax is not the best for you. Maybe you go and pick a different kind of wax.